Hi everyone. In this lesson, we're looking at linking geometry concepts with trigonometry to solve real-world problems. And the first bit of vocabulary we have here is the three-dimensional coordinate plane, and I'm showing it here. So in a two-dimensional coordinate plane, we're looking at an x and a y axis, and in a three-dimensional coordinate plane, we're looking at an x, y, and a z axis. Now, primarily what we're doing in this lesson is using formulas that you should have already seen in the past. And all of the formulas are in the formula booklet. So I have, just as a reminder, if you go to your formula booklet and you look at topic 3, you'll see that there is the distance formula in a three-dimensional coordinate plane. There's also the midpoint formula, all right, in a three-dimensional coordinate plane. As a reminder, some geometry notation. AB is used to denote the line segment with endpoints A and B, and that's how the IB will denote it. If you're talking about a line segment, AB, you may also see it with just a line over it. AB without anything over it is going to be used to denote the length of AB. So when we say find AB, we're asking for the length of AB, so you know you're going to be using the distance formula. So example 1, I'm asking you to find the midpoint and the length of AB. And I have an IB tip here. One of the best ways to show working and gain credit in IB exams is to write down the formula, substitute, and evaluate, and provide a clear mathematical layout. Keep your work aligned under the equal sign as you go down the page. All right, so we're going to find the midpoint first, and so we're going to write out the formula for the midpoint. And before you fill in the formula, you may want to just label your coordinates. For A, I'm going to call that x1, y1, and z1. And for B, I'll call that x2, y2, and z2. And then we're just going to fill it in. And when we solve that, we're going to get the value 2, 2.5, and 6. Okay, moving on to the length of AB, we're going to write down the distance formula. Okay, I have the formula written. Now I'm going to fill in the formula. And just a little side note, I mean, you don't have to write the formula. You're not going to lose points in IB if you don't. But if you're really a little bit uncertain, it's helpful to do that. You'll gain some credit for doing that. All right, so let's fill in the formula. And we'll simplify. And our final answer will be 3. Okay, moving on. Pyramids, cones, and spheres. The base of a pyramid is a polygon, and the 3 or more triangular faces of the pyramid meet at a point known as the apex. In a right-angled pyramid, the apex is vertically above, so it's directly above the center of the base. So we have different size bases here, different polygons. We have a square, we have a triangle, we have a hexagon, right? Those are all pyramids. There's a close relationship between pyramids and cones. The base of a cone is a circle rather than a polygon. So we have a circle. So it does not have triangular faces. A sphere is defined as the set of all points in a three-dimensional space that are equidistant from a central point. Half a sphere is called a hemisphere. All right, so a lot of vocabulary. Also in the formula booklet, under prior learning, we have all of these formulas. I'm just making it clear, you're going to be using your formula booklet a lot in this unit. Under topic 3 in the formula booklet, we have all of these formulas. In example 2, we're asked to find the volume and the surface area of a cone. So we're going to write out the formula for the volume of a cone. And so the formula for the volume of a cone is given in our formula booklet. It's right there. So let's write that out. 1/3 pi r squared h. And then we're just going to fill in right under the formula. So our volume is going to be equal to 1/3 pi, our radius is 3, and our height is 4. So 3 squared is 9, divided by 3 is 3, 3 times 4 is 12, so this is 12 pi. And if we were to multiply out the pi, we would get 37.7 centimeters cubed. And keep in mind that volume is a cubic unit, area is a squared unit. All right, so if I want to put 12 pi in my calculator, and remember, we do not want to round to 3.14. All right, we're going to use the pi button that's in the graphing calculator. So 12 pi, we would do 12. And then to get the pi button, it's, I'm going to highlight, you'll see it highlighted in red. You're going to have to do second, and there it is. Hit enter, and so we're going to get 37.7 centimeters cubed for example 2. Now we're going to write out the formula to find the surface area. So we need to add the area of the base, which in this case is a circle, to the area of the curved surface of the cone. The curved surface of the cone is pi RL. L is the slant height, so 5 in this case is L, and now we're just going to fill in the formula. Okay, so we're going to get 9 pi plus 15 pi. So that's going to give us 24 pi. And if we multiply that out, we're going to get approximately 75.4 centimeters squared. All right, so we're using our formula booklet to look up those formulas and then just fill in the information nice and neat when you're done. Last one here, moving on to example 3. A cylindrical can holds 3 tennis balls. Each ball has a diameter of 6 centimeters, which is the same diameter as the interior of the cylinder, and the cylinder is filled to the top. How much space in the cylinder is not taken by the tennis balls? Well, I really like a good diagram, so I'm going to draw a cylinder with 3 tennis balls in it. You don't have to be this exact, but I'm going to do that. So just give me a second here. All right, so I kind of have a rough sketch there. Now I'm just going to label it up. The diameter of each ball is 6. So I'm saying from here to here is 6, here to here is 6, here to here is 6. That means that the radius of each ball is 3. Okay, so I want to find out how much space is in the cylinder that's not taken up by the tennis ball. So I'm going to write out what I need to do in words to start. So I need to know, what the volume of the cylinder is. And then I'm going to subtract out the volume of the 3 balls. So the 3 times the volume of a ball. And in geometry, we refer to a ball as a sphere. So we're going to use our formula booklet to write out these formulas now. The volume of a cylinder is pi r squared h. and the volume of a sphere is 4/3 pi r cubed. And then we're just going to fill it in like we've done for everything else. The total height of our cylinder is 3 times 6, 6 plus 6 plus 6, that gives us 18. 3 times 4/3, that's just going to leave me with 4 pi and then r cubed. So if I do 9 times 18, I get 162 pi, and I like to keep things in terms of pi until the end. 4 times 3 cubed, that's 4 times 27, that gives me 108 pi. 162 pi minus 108 pi is 54 pi. And if I multiply 54 by pi using the pi button in my calculator, I'm going to get 169.65. We're talking about volume, so we know it's units cubed, in this case, centimeters cubed. All right, so that's all I have for this video. My recommendations would be do a sketch, and all else fails, do a sketch that usually helps you decide how to approach the problem. And it doesn't have to be anything fancy. You could see what I did here. I mean, just a rough sketch can really help. Just put something on the paper, especially if you're taking the IB exam, and get some points at least for making an attempt. All right, good luck, everybody. Have a great day.